We're going to be working with literal equations and formulas in this section and really working to rewrite these various equations, and in particular, looking to isolate one of the variables contained inside of those literal equations. So first of all that a literal equation basically is it's just going to be an equation, which of course means it has an equal sign, and literal just refers to letters. So examples of literal equations would be like if you have 5xy minus w is equal to 3z plus 4, right? Just something that's got letters. Now, specifically, formulas are always going to be literal equations because when we think about formulas, they're going to have letters involved with them. But what makes a formula maybe a little bit more specific than a literal equation is that formulas should really kind of be, useful, like things that we would actually use, like distance equals rate times time, or that half times the base times the height of a triangle, so it can give you the area of the triangle, etc. So getting into examples here, what we're asked in this very first problem here is to be able to solve the formula c equals 2 pi r for r. So this is referring to the circumference of a circle, and if you recall that the circumference of a circle is just the distance all the way around the circle. Basically, circumference is just a fancy term for the perimeter of a circle. And so what it means to solve the formula for r is that we actually want to get r alone in the equation. And so in this equation, we've got circumference equals 2 times pi times r, and this r right here is what we're trying to solve for, so we actually want to get that alone on one side of the equal sign. So in order to get that alone, then of course, like these sorts of things, right, we want to be able to get rid of them. And to undo them, you have to think about the operations that you need to use to be able to undo that. And so if currently 2 and pi are actually both multiplying with r, then you can do the inverse operation of multiplication, which is division, and you can divide by 2 pi then, because we know that 2 pi divided by 2 pi will just equal 1, so you're going to get 1 times r, which of course is r. Now, because it's an equation, right, we know that to keep the equation balanced, we have to do the same thing to both sides to do so, and so what we're going to get then is we're going to get c divided by 2 pi then is equal to 1r, or just r. And so that would correctly solve that equation there for r in terms of all of the other variables and numbers that we have going on there. Just note that if you did write this kind of more horizontally, if you wrote c divided by 2 pi, we want to make sure that you actually divide by both the 2 and the pi, so you're going to have to make sure that you do have the parentheses there so that we have the correct order of operations and such going on there. Jumping over to the triangle, this here is the area of a triangle, of course, half times base times height. We're asked to solve the formula for the variable b. And so if I write out this formula first of all right here, you can see that we're going to have to undo a couple things. We're going to have to undo the multiplication of 1/2. So if we just focus on that part first of all, in order to undo the multiplication of 1/2, you can multiply by the reciprocal. So if I multiply by 2, then we know that right there, 2 times 1/2 is just going to be 1, right? So you end up getting then b times h, but we have to do the same thing to the other side of the equation to keep this balanced. So in that first step right there, just by multiplying both sides by 2, I get 2a is equal to bh. And then in order to get the b alone that we're trying to solve for, we're going to have to undo the h multiplication, which you can do by division. So you can divide that by h, and we know that there, h divided by h will equal 1. So you just get b times 1, which is b. And then that side gets divided by h as well. So you're going to end up with that 2 times a, and it's still going to be capital. You can't change the case of these letters because sometimes in math, capital letters and lowercase letters are actually different variables. So we got to leave it as it is, and that would solve that particular formula there. The next one here is kind of a little interesting little thing here. So it turns out that if you have a hexagon, the distance from the center of the hexagon to one of the corners, that's actually called a radius, kind of like when you have a circle, right? And then if you go from the center of the hexagon and then you go to like the middle of where a side is, that's referred to as the apothem of the hexagon. And it turns out that we have this identity or this relationship between the radius and the apothem, so that if r is of course the radius and a is the apothem length, that r is equal to 2 times a divided by the square root of 3. So what we're asked to do here is we're asked to solve the formula for a, for the apothem. And so we have to think about what sorts of things we need to undo, and it's really undoing things in the reverse order of what was done to what we're solving for. And so what I mean by that is if we're solving for a, you can see that a is actually first multiplied by 2, and then that's divided by 3. So to undo this, we need to go backwards, which means we need to undo dividing by 3. So to undo dividing by 3, you need to multiply by the square root of 3, because then we know that that right there is just going to equal 1 and undo things there. But then we're going to have to do the same thing to the other side, which is to multiply by square root of 3. So we get square root of 3 times r on that left side equals 2 times a. And then if we want to get that a alone, we're going to have to undo the multiplication by 2, which we can do by dividing by 2 to both sides. So we do end up getting that square root 3 over 2 times r is equal to a there. And then moving over to where we've got the rectangle there, we're asked to solve the formula for a perimeter of a rectangle, which of course is going to be adding 2 of the lengths of the rectangle together with 2 of the widths of the rectangle. We're asked to solve this for w. So writing this formula out. So the thing about this formula is that if we're solving for w, we do have to acknowledge the fact that there are actually multiple different terms on that side. So if you do have multiple different terms, the very first thing you'll want to do is then get the term alone where you have the variable that you want to solve for, and then all the other terms, get them over to the other side. So this term, I want to get to the other side somehow, and really that 2L is being added on this right side. So I actually need to subtract 2L to both sides of this, because what will happen right there is that if you take 2L and you subtract 2L, that's really just going to equal 0. And so you get 0 plus 2w, which of course is just only 2w. So then on the other side, you really just have p minus 2l, which you just leave as it is because those are not like terms. And then finally, just kind of one last step. We want to get the w alone. We got to get rid of the 2 there. And so we can think that we could divide by 2. Now, of course, we know that dividing by 2 is also the same thing as multiplying by half, right? That if we do 2 times a half, that's just going to equal 1. And so then when I do so to the other side, because there's multiple terms, that 1/2 has to multiply to everything. And so if you wanted to, I guess you could distribute that 1/2. And so you would get 1/2 p. And then if you do 1/2 times -2, that's -1. And so it does turn out that the width right there will be half the perimeter minus the length. And then a couple more geometric types of formulas that we're seeing here. What we see here is we see the surface area formula for a cylinder right there. And we want to solve this formula in terms of h. And so this is somewhat similar to kind of what we just saw, because when we are trying to solve for the variable h in this one, which is right there, you can see that it's belonging to this term, but there's also another term on the same side of the equation. So we're going to have to cancel out that other term first before we think about anything else. And so simply all that we're really going to do here is we're just going to go ahead and subtract the 2 pi r squared, because then if you subtract that term and then you have that term being added on that same side, they're going to cancel each other out. But then, of course, that means we're going to have to also subtract 2 pi r squared to the other side as well. So that's then going to give us, that's the surface area minus 2 pi r squared is going to be just equal to 2 times pi times r times h. And again, we're trying to solve this formula for h. And so now it's just you have 2 times pi times r that you can cancel out if you divide both sides by 2 pi r. And so we're going to divide this whole side by 2 pi r as well. And so it does turn out that when you've got multiple different terms on the top there, but you're just dividing everything by 2 pi r, you could write it in a couple different ways. So option number 1 is you could just leave it like that. Now, option number 2 is that you could also have it as the surface area divided by 2 pi r, and then also have it as 2 pi r squared over 2 pi r. But it does turn out like, 2 divided by 2 is 1, pi divided by pi is 1, and then when you do r squared divided by r, you really have like r times r over r, which means that r divided by r will equal 1, which just really leaves you kind of an r left over. So it does actually turn out that that could be an alternative way that you write that out. If you just want to leave it as h equals surface area minus 2 pi r squared all over 2 pi r, like that's fine too. So either way is fine, whether you have that or whether you have that. They're both equivalent sorts of forms. And then the last sort of geometric example I want to show here involves a trapezoid. So we call that a trapezoid is a four-sided figure where just exactly one pair of sides are parallel and then the other two sides cannot be parallel. Otherwise, it's going to have to be a different shape. It's not a trapezoid. So the area of a trapezoid can be determined by taking the sum of B1 and B2. And B1 and B2 are always going to be the lengths of the two sides that are parallel, and then whatever the distance is perpendicular between them, that's referred to as the height. So we first of all want to rewrite this formula in terms of h. So if we're going to solve this particular formula for the variable h, then we're going to have to get rid of like this 1/2 and this b sub 1, b sub 2 sort of stuff going on right here. So you actually don't really need to distribute necessarily because you just have this, and because that's in parentheses, you have times that, times with that. So it's really just undoing the multiplication of 1/2 and then undoing the multiplication of the quantity of b sub 1 plus b sub 2. And so one first thing that we could maybe do to both sides is just go ahead and multiply it by 2, because we know that 2 times 1/2 is just going to equal 1. So that's going to give us 2a equals just the sum of b sub 1 with b sub 2 times h. And then you can actually just undo the multiplication by b sub 1 plus b sub 2 by just dividing by that quantity of b sub 1 plus b sub 2, because then that divided by that is going to equal 1, and then you get h alone. Just got to make sure, of course, that you do that to both sides. So you could write it like this, that 2a divided by b sub 1 plus b sub 2 is going to equal h. If you were to write that horizontally, just make sure that if you are really going to be dividing by b sub 1 plus b sub 2, that if you write it this way, of course, you're going to have to write that in parentheses and then have that there solved for h.